So hello everyone, welcome back. So in this session we are going to discuss Cardano Governance. And for talking about Cardano Governance, we must come back to the very early days of Cardano and how it all started. So it all started with a federated system. We had Emurgo, Input-Output, and Cardano Foundation, and these three entities were the only ones responsible for block production and for the governance of the system. When we transitioned to Shelley, we decentralized the block production. We distributed the responsibility of block production, so now it is in hand of stake pool operators. But until the Voltaire era is released, the governance of the system is still in hands of Input-Output, Emurgo, and Cardano Foundation. So what that means is that these three entities have the responsibility of still taking the decisions about the protocol parameters. The protocol parameters, as we have said before, is like the rules that govern and shape the behavior of the system. So the mechanics of this is very interesting. So we have this concept of a genesis key, where a genesis key is basically a key pair that is referenced in the Byron Genesis file. And these Genesis keys have these two powers: signing blocks and updating the protocol via an update proposal. But these keys do not do it by themselves. They don't really use the Genesis keys, but we have this concept of delegation. So Genesis keys actually delegate their powers to a delegate key via a delegation certificate. So it is now the delegate key, the one that actually has the powers to sign blocks and to create and vote for update proposals. Of course, this delegation can be changed at any time. So in mainnet, we have this collection of 7 Genesis keys, 7 delegation certificates, and 7 delegate keys. For those of you that are curious, go to your Byron Genesis file and you will have the mapping. It says heavy delegation, and you will have this. This is like the hash of the Genesis key. You have the delegation certificate, the delegate public key, the issuer public key, and finally the omega, which means the epoch since when this delegation is valid or active. And of course, you have 7 keys like this in the Genesis file. And this mechanism of update proposals is what has enabled the development of Cardano in the way that it has come. That is, in stages, in phases, where we have been releasing features slowly and steadily. So everything started with Byron and the Ouroboros Classic implementation, with the Cardano SL implementation. And unfortunately, that implementation was not that good, so we had to go through the Byron reboot process, so everything was to be written from scratch. And we had like the Byron reboot event, and that we switched to a different version of the protocol that was Ouroboros BFT. And with that, we got ready for what was coming, that was Shelley. With Shelley era, we developed and released the decentralization of block production. With that, we bring rewards, stake pools, and all of those concepts of incentives. And that was protocol version 2. Then we went to Allegra with token locking, later to Mary with native assets, which enabled a lot of very cool things, because now you can have your own token that runs on layer 1, so you don't need a smart contract or anything like that, like in other platforms, in other chains. So that was very powerful. And then we bring Alonso with the smart contracts with Plutus. And in Alonso, we had like protocols versions 5 and 6. And finally, the current era where we are now, that is Babbage, where we have the Vassal hard fork that brought Plutus version 2, reference input, inlane, datums, reference script, all of them targeted to dApp developers, to decentralized applications, to make them more efficient. And of course, also we brought the removal of the decentralization parameter. Soon, in the very few days, we will have also an intra-era hard fork within the Babbage era, which will bring protocol version 8, and that is for introducing the SecP primitives that will enable some bridges with other networks. So this development in stages is powered or is possible thanks to the update proposal mechanism. And let's see how this update proposal mechanism works. So we have to differentiate this update proposal mechanism in terms of when it occurs. So we have a mechanism that is exclusive for the Byron era, and then we have the mechanism that is valid for Shelley and later eras until Voltaire era, where this will change again, and we don't know yet exactly the details. There is a Cardano improvement proposal for that is still being discussed. So until that point in time, when we have Voltaire era released, governance of the Cardano blockchain is still in a federated mode. So only Cardano Foundation, IOHK, and Emurgo can actually propose and vote update proposals. So let's go back to the Byron era and see how it works on that time. So everything started with the creation of the update proposal. A delegate key must submit that update proposal to the blockchain via a special kind of transaction that we had in Byron. So when this delegate key submits that is registered on chain. So that is a ledger event that is actually reported back into the logs. And that opens what is called a voting period. So an update proposal needs to accumulate a certain number of votes. There is a threshold for that. That was a protocol parameter. And that threshold, when that is met, that means that sufficient number of other delegate keys, and even the one that proposed it, have voted positively for this update proposal. So it accumulates votes. So if you think about it, this last vote is still at the tip of the chain. So we need to wait some time for it to be deep enough so that we are certain that we are not changing to a different fork, so that nothing will change, so that we may switch to a different fork that does not contain that last vote that confirmed the proposal. So we need to wait 2K slots, where K is the security parameter. We wait 2K slots. Remember that in Byron era, we had a block at every slot. So we need to wait 2K slots for the update proposal to be stably confirmed. So now the last vote that confirmed the update proposal is 2K slots deep in the chain. And that opens what is called the endorsements window. And that is a special mechanism that is exclusive to Byron. It disappears later in Shelley era, but it's a very interesting one. And so you have voted positively for the proposal. That's fine. But that's not sufficient for the proposal to be adopted. Now you need to endorse it. Remember that we are in a federated mode where the delegate keys not only run the governance of the system, but also the block production. So to guarantee that the block production continues correctly, the block producers need to update their software to a later version that is compatible with the version that is proposed in the proposal. So when you update your node, you start signing blocks with your new version that is announcing in the block header that you are ready to move to that that protocol version, then that is called an endorsement. So you are saying, I am ready for that update and for adopting this proposal. So at that point in time, when we accumulate sufficient endorsements, then we have a candidate. But again, this candidate, this last endorsement, is still at the tip of the chain. So we need to wait some time for it to be deep enough so that we are certain that there is no possibility that it changes. So we cannot fork to a different chain that does not contain that very last endorsement. So, or any of the endorsements that actually give us beyond the threshold. So once that last endorsement is 2K slots deep, we have a stable candidate. And from here, we have a very important window of time. So we have this point in time, which is 4K slots before the end of the epoch. So if the last endorsement arrived earlier than this point in time or later of that point in time, determines the path that the update proposal will follow. So in the first scenario, where it became a candidate earlier than this point in time, earlier than 4K slots to the epoch boundary, if it becomes an unstable candidate, then the proposal will be adopted at the very next epoch change. On the contrary, if the last endorsement was registered later than this point in time, then if it becomes a stable candidate, it will be adopted, but the adoption will be delayed for one entire epoch so that we all have sufficient time to be ready. So what happens here is that we don't want to be switching to a new protocol version when it is just announced very close to the end of the epoch. So if that happens, that's totally fine. We just delay the adoption for one entire epoch so that everyone is ready for that. And this is how Byron update proposals work. Let's go now to see how Shelley and later Era's update proposal works. So the mechanics is more or less the same with some tiny differences that actually are worth mentioning. So again, everything starts with a delegate key submitting an update proposal. This time, unlike in Byron, there is no special kind of transaction. It is submitted via a regular transaction that pays transaction fees and all of that. So again, the update proposal is registered on chain. This is a ledger event that is reported back in the log so that everyone knows that, okay, there is a update proposal registered here. So we also have some time windows that are important here. So there's a critical point in time here that is 2 times the security, the stability window, and that is 6K over F slots before the epoch change. In mainnet, for practical reasoning, this is 48 hours into the epoch or 72 hours before the end of the epoch, depending on when you want to see it. So we have, again, the other delegates keys, and including the one that submitted the proposal, have to vote. But this time, even the one that submitted the vote doesn't have to actually do anything because it submitted the original proposal. So that's counted as a vote. And the other delegate keys that want to vote for that proposal, they no longer have this mechanism of actually producing a vote and submitting it to the chain, but instead, to vote and endorse a proposal, they need to basically submit the very same update proposal to the chain. And once we accumulate sufficient votes, we can be sure that it will be adopted. But there's a mechanism here. Again, we have like a threshold. We have a minimum number of keys that need to vote for that proposal, and that is the quorum. We saw that in the protocol parameters. So once we accumulate sufficient votes, if that last vote arrived before this point in time, so it is before within the first 48 hours of the epoch, then this update proposal will be adopted at the very next epoch transition. There is no endorsement mechanism or anything like that here. But there's a special scenario here where what happens if that last vote arrives later than this point in time. Well, nothing happens, it's all good. We register the quorum, so this proposal will be adopted, but not at the very next epoch transition. We don't want changes when this thing is announced very close to the epoch change, but instead it will be delayed for one entire epoch until the epoch change from epoch n+1 to epoch n+2. So it is adopted, just delayed for one epoch so that everyone is aware of it and everyone is ready for that. But also there is this special scenario where what if you submit an update proposal within this window when there are only 72 hours left of the epoch? Well, there is a special procedure for that. And you can submit this update proposal if and only if you specify that this update proposal is supposed to be valid for epoch n+1. And for valid, we mean that the voting period will start here and the quorum will be monitored around this window here. So nothing will happen during this epoch if you submit it here, and you must specify that it is valid for epoch n+1, and this is enforced by the Cardano CLI, so that you cannot submit an update proposal if you don't specify that it goes for the next epoch if it happens during this window. If that happens, well, everything goes exactly as before. It is as if it was submitted here, and the mechanics go exactly like that. So this is the different paths that the update proposal can take in Shelley and later eras. Final note, in Shelley and later eras, one epoch lasts 10k over f slots, where k is the security parameter and f is the active slot coefficient that we saw in the protocol parameters, the parameter f from the Ouroboros Browse paper. Final note, in the Byron era, an epoch lasts 10k slots. So this will be relevant later when we actually deploy a local cluster, and we will bring that local cluster all the way up from Byron era to Babbage using proper update proposals, so that you all get the feeling of how these update proposals worked in practice, not only in theory with fancy diagrams, but actually hands-on. We are going to see how it works. And that's exactly the next section. So see you there.